Hi, in this lesson we're talking about kinetic energy. Kinetic energy is defined as, so if we go back, kinetic energy is defined as the energy of motion. So let's get started. What is kinetic energy? Well, as we just stated, it's the energy of motion. Energy of motion. But what does that mean? It basically means the energy of a moving object. Like think about, for example, when you're running, it takes you a lot of energy to stop yourself from running because you are in motion. And what kinetic energy depends on is it depends on two variables. It depends on think about when you're running, well, what's going to cause you to be hard to stop? Well, if you weigh more. The mass, so it depends on mass, and your velocity. Because, let's think about, for example, a train. A train may not be moving really fast, but it has a lot of mass, so it takes a long time for it to stop. Versus, for example, if you talk about a baseball. A baseball may not have a lot of mass, but it has a lot of velocity, so that's also very hard to stop. But if you talk about you just gently throwing a ping pong ball that has low mass and low velocity, then it doesn't have much kinetic energy, and you can stop it. So the formula of kinetic energy then is this. Ke, which stands for kinetic energy, is equal to 1/2 mv squared. Where m is mass in kilograms, v is velocity in meters per second, and kinetic energy is in the unit joules, or J. So let's look at how kinetic energy applies to work. Well, when we apply a force to an object at rest, it starts to move. As we do this, we have done work and the velocity changes, so we're changing kinetic energy. Okay, so that means when you are changing kinetic energy, if we keep applying that work, the velocity continues to change. So you apply work, this changes velocity. Which thus, because velocity is in kinetic energy's equation, it changes Ke. Now how does it change Ke? Well, you could find this because you know that if you apply any work, you would know what the final kinetic energy is, and you'll know what the initial kinetic energy. Hey, that means, in a sense, it's subtracted. It's the initial kinetic energy, which means that work is the change in kinetic energy. So let's practice these examples. What is the kinetic energy of an object that's traveling at 25 meters per second? That's your velocity, and has a mass of 150 kilograms. That's your m. So kinetic energy is equal to 1/2 mv squared. Kinetic energy is equal to 1/2 150 kilograms times 25 meters per second squared. Well, if we plug this in your calculator, what do we get? You would see that you will get, in this case, 0.5 times 150 times 25 squared. You get 46,875. 46,875 joules. Now be careful, when you plug this in your calculator, the square is only applied to the velocity. So make a note for yourself. The exponent only applies to the velocity. Because what will happen a lot of times, students will do is, they'll do this. They'll do 1/2 times 150 times 25, and then they hit square, and they get 3,515,625 joules, and that's a lot of energy. But that's actually not how much energy it should be, because you gotta remember bed mass. In bed mass, exponent is done first. So 25 squared should be done first, then you multiply. Okay, let's try example number 2. What is the mass of an object that has a kinetic energy of 5,650 joules and is traveling at a speed of about 60 meters per second? So in this case, kinetic energy is equal to 1/2 mv squared. Kinetic energy in this case is 5,650 joules. Is equal to 1/2 m. V is 60 meters per second squared. To isolate for m, we're going to multiply both sides by 2. Okay. What you're going to get is you're going to get this value. 2 times 5,650 is 11,300. 11,300 is equal to 60 squared times m. What you want to do now is divide both sides by 60 squared. And you're going to get a mass of 3.14. So mass, in this case, you divide both sides by 60 squared. M is equal to 3.14 kilograms. So that's one way of solving this. Of course, you could have isolated first. If you isolate first to solve for m, if you know your algebra, if this was your equation, mv squared, you could have isolated first, multiply both sides by 2. Okay, you're going to get 2ke is equal to mv squared. Divide both sides by v squared. Right? You're going to get m is equal to 2ke over v squared. That could have been done beforehand, and then you could have plugged in your equation, your numbers. Let's go to our last example. What is the speed of an object that has a kinetic energy of 56,400 joules and is 2,500 kilograms? Okay. So in this example, let's actually do our isolation first. So kinetic energy is equal to 1/2 mv squared. Let's isolate first by trying to solve for v. So in this case, what do we have? Well, if we multiply both sides by 2 to start off with, we're going to have 2ke is equal to mv squared. Our next job, divide both sides by m, because we're trying to isolate for v. We're going to get 2ke, 2 times ke over m, is equal to v squared. How do we get rid of a square? Well, we apply the opposite, inverse operation. That's square root. If we square root a square, that gets rid of that. So what we're going to get is we're going to get v is equal to the square root of 2 times kinetic energy over m. So if I were now to plug these values in, I will get 2 times 56,400 joules divided by 2,500 kilograms. Let's see what we get. So we do 2 times 56,400 divided by 2,500, and I square root that. And I'm going to get a velocity of 6.72 meters per second. 6.72 meters per second. So, make sure you practice using this equation, knowing how to isolate variables. As always, make sure you keep yourself safe and healthy, and I'll see you soon.